Today our topic is electric potential due to a point charge. Potential at a point due to multiple charges. Today we have two topics. One is the net potential at a point due to a number of charges or multiple charges. And second one is potential energy of a system of charges. First we will see potential at a point due to a number of charges. So suppose we have a point here. Surrounding the point we have many charges like this. Q1 is a charge here. Then we have a charge Q2 here. This charge is at a distance. I will mark as R1. This is at a distance R2. One more charge here Q3 at a distance R3. At this point P, we need to find the net potential. So at this point P, all the three charges will produce electric potential. This charge is at a distance R1 from here, here R2 from here, and here R3 from here. Potential is a scalar quantity. So what we can say, we need to just add these three potentials. So what will be our equation? Net potential at P, V is equal to potential due to this charge. What is the equation? Due to point charge, we have the equation 1 by 4 pi epsilon 0 charge divided by distance Q1 by R1 plus potential due to this charge 1 by 4 pi epsilon 0 Q2 by R2 plus 1 by 4 pi epsilon 0 for this charge. What is the potential? Q3 by R3. So we have three potential. We have added them because potential is a scalar quantity. Now we can take common 1 by 4 pi epsilon 0. It will be equal to Q1 by R1 plus Q2 by R2 plus Q3 by R3. This is a net potential at the point P. So net potential at point P is equal to algebraic sum of potentials at a point P due to the individual charges. We have to consider these distances R1, R2 and R3. Q1 by R1 plus Q2 by R2 plus Q3 by R3, the whole into 1 by 4 pi epsilon 0. This is the net potential at the point P due to these three charges. Okay. Now we have one more topic, potential energy of a system of charges. We will see what is potential energy. How can you relate potential and potential energy? So we need two terms. We have two concepts here: potential and potential energy. We have learned that potential difference or potential V is equal to work by charge. So if this is a work by charge, what is work done? The work done is equal to potential into charge. Work done is equal to potential into charge. Work done is equal to potential energy. Or we can say potential energy is equal to V into Q. This is equation for potential energy. The work done is equal to the potential energy. Okay. This equation we are going to use here. We have a system of three charges. Potential energy is equal to potential into charge. Potential into charge is potential energy. And now we will consider three charges. System of first we will consider two charges. We have Q1 kept here, Q3 kept at this point, sorry, Q2 kept at this point. Distance between them is R12. Symbol is R12. R12 is the distance between charge Q1 and Q2. Now we are bringing the charges from infinity to this point. So initially we didn't have the charge Q1. Don't have the charge Q2. I am going to bring the charge from infinity. I am bringing the charge Q1 to this point. So I have brought the charge here. Here we don't have any other field. Only we have the charge Q1 here. So while bringing from infinity to this point, there is no electric field here. So if there is electric field, we need to do some work. If there is no electric field, there is no repulsion or no attraction, no need to do any work. So for bringing Q1 charge, do we need any work? No, we need not do any work. I can say the work W1 to bring the charge W1 is equal to 0. Now I will bring the second charge here to this point. The charge was Q2. I am bringing charge Q2 here. From where I am bringing charge? From infinity. I am bringing it here. Now the problem is At this point, there is already an electric potential. What is electric potential? At this point, I will mark this point. At this point, the electric potential is, I will say it is a V1. What is electric potential? 1 by 4 pi epsilon 0 Q1 by R12. Q1 by R12. This point has a potential. At this potential, what I am going to do? At this point having a potential V1, I am keeping another charge, bringing another charge having a value Q2. So I need to do some work, because we have learned that work done is equal to potential into charge, which is a charge I have brought here Q2. What is the potential at the point? It is V1. So what is the work done? I can say W2 is equal to potential V1 into what is the charge? Q2. V1 into Q2. I will multiply these two together, Q1 and V1. What will be the work done? Work done is equal to 1 by 4 pi epsilon 0 Q1 by R12 into Q2. This is the work done. So I got work done. First case work done was 0. Second case work done is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12. Now I have one more charge. I will bring the charge at this point. This point is at a distance R13 from here, and from this charge it is at a distance R23. At this point I am going to bring a charge from infinity. I am going to keep a charge here. So this point is under the potential of these two charges. For Q1, I can say the potential due to Q1 at this point, I will give another symbol. Due to Q1, the potential at this point is, I can say V2. So I can say V2 at this point, V2. What is the potential due to Q1 at this point? V2. It is equal to 1 by 4 pi epsilon 0 Q1 by R13. This point has potential due to this charge also. So both points are same. So what is the potential at this point due to this charge? I will mark the symbol as V3. Due to this charge, it is equal to 1 by 4 pi epsilon 0 Q2 by R23. R23 is the distance. So this potential is under that point is at the influence of two charges. There are two potential. One potential due to this charge. This is the potential. Due to this charge, this is the potential at this point. My aim is to bring another charge here, and I am going to bring charge Q3 here. I want to bring it Q3 here from infinity to this point. So what is the work done? There are two potentials. Against two potentials I need to do work. I can say the work done by me will be equal to W3. First work done against V2, I can say Q3 is a charge and V2 is the potential, plus V3 is a potential and Q3 is a charge. So Q3 charge I am bringing to a point having two potentials, Q3 and V2 and V3. So Q2 into V2 plus Q3 into V3. So we need to multiply Q3 into V2. This one, it is equal to 1 by 4 pi epsilon 0. This is V2 into Q3. Q1 by R13 into what? Q3. Plus, this is first term. Now Q3 into V3. This I need to multiply by Q3. So it is equal to 1 by 4 pi epsilon 0 Q2 then Q3 divided by R23. So this is the work done, W3. So to assemble these three charges, I have done work. First case, to bring Q1, there was at that time when I brought Q1, there was no other charge. So I didn't do any work, so W1 was 0. When I brought the charge, which charge I have? When I brought the charge Q2 here, I have done a work W2. Work is equal to potential into charge. When I brought another charge here, this is under influence of two potentials, so the work done is W3. Two terms are there. So what is the net potential? Net work done. Net work done, I need to add these three works. Net work done is equal to what? W1 plus W2 plus W3. This work done is called the net potential energy of the system. Total work done. So I can say total work done is equal to, I need to add W1, W2 and W3. In all these 1 by 4 pi epsilon 0 is common. Then first term, what is first term? Q1, Q2 by R12. This term, Q1, Q3 by R13 plus final term, Q2, Q3 by R23. This is the net work done. This net work done is equal to potential energy, we can give the symbol U. So U is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q2 Q3 by R23. This is the total work done and it is equal to total potential energy of the system. Remember, we have brought 3 charges from infinity to these 3 points. These 3 points initially didn't have any electric field. So this was a region free of electric field initially. Then in that region I have brought Q1 charge here, then Q2 here and Q3 to this point. So I have arranged it like in the form of a triangle. Then this is the total work done to arrange, and this total work done is equal to total potential energy of the system. Okay, thank you.